Good evening, everyone. Thank you for attending the fifth session of the Tri-County Winter Webinar Series. I'm Emily Lindenfelser. I've been hosting you guys throughout this whole series, and thanks for joining us again tonight. We are with Shane Bugeja, and he'll be talking about some soil basics tonight. But before we get started, just wanted to remind everyone that if you have any questions, please put them in the Q&A on the bottom of your screen, and then we'll get to them at the end of the presentation. And if you have any comments or if Shane is going to do any activities for us tonight, put your answers in the chat. And if you want to chat with other people, feel free to do that as well in the chat box. And that is also at the bottom of your screen. So without further ado, I will give it over to Shane. And Shane, you can introduce yourself a little bit and talk about your role as a tree care advisor.
Sure. Thanks, Emily. As Emily introduced me, my name is Shane Bugeja. I used to be part of Extension, so I was lucky enough to work with Emily and her other colleagues. But today I'm going to be speaking as a tree care advisor. I work for the Minnesota Board of Soil and Water Resources, but today I'm going to get some volunteer hours in. I don't know if there's any master gardeners in the audience, but we try to get our hours where we can, no matter what volunteer organization we're part of. But I want to welcome you today. I'm going to talk a little bit about soil. We're going to try to keep what I want to try to do is start small and try to move bigger, and then address a few things that I commonly saw when I was an extension educator in my area in southern Minnesota. And I'll add a few things that are very specific to trees, but broadly, I'm going to be touching on vegetables too. A lot of these things work are true no matter what is growing in the ground. So the first thing I want to do is, and we'll get your fingers warmed up. I want you guys to try to define soil in a couple, like a short sentence. What do you think of when you think of soil? What would be your definition of soil? And as people are thinking about that and writing in the chat, this is not an easy answer. When I was in grad school, I was in the Soil Science Society of America's meeting, and there was extremely heated session. People were arguing and kind of yelling even. So if you can get soil scientists really angry and passionate and heated, it's kind of maybe a good question. So if anybody, what do you guys think of? Let's see a few of these. Earth, clay, and rock particles from Lena. Okay. Soil growth media for plants. Very good. Yep. Soil's not just dirt. Emily wrote a bad word here for me. When you hear the word dirt, I think of it's soil out of place, right? Just like a weed could be a plant out of place. Microbes, minerals, and bacterium. Ooh, I like that, Susan. Okay, great. All right. If there's any more, I am all ears, but those are some good ones. A lot of times we're looking at these and we know that there's a mineral part, right? There's some not living stuff, but a lot of your answers had living things part of it, which is great. That's exactly what I wanted to see. So we'll go with the Soil Science Society of America's definition. So after they were done arguing and almost coming to fist fights, they came out with this kind of sentence here. And it was pretty, I have my own opinions about this, but this is kind of what the Soil Science Society of America thinks. It is the surface mineral and or organic layer of the earth that has experienced some degree of physical, biological, and I put that in red, and chemical weathering. And it's not like physical or biological or chemical. It's all of those together. So when we talk about soil, you cannot separate soil from life in some way. So that's what makes things soil and not regolith, which is a really dumb, boring geology term. So when people talk about like Martian soil or moon soil, I get kind of, unless they find something that is that I don't know about, that's sometimes I can get a little prickly about that. So life is super important for how soils are formed. And we'll dive in a little bit deeper. So there's something called the soil forming factors. I know it from there's a scientist called Hans Jenny that came up with these. You might hear it like the clorped. I don't know. I don't really like that one. I think of it as Jenny's uh, soil forming factors. So how your soil comes to be, obviously it might be in a place. The topography, is it a start off on a cliff? Does it start off kind of on a low elevation? So kind of the topography is really important when we're thinking about soil, and that can change things quite a bit. It can, of course, living things. So when we think about what can weather soil, rocks or other minerals, something that doesn't need a lot of really deep soil. So lichens, mosses, all of those have little acids that they use to break down minerals to release nutrients. And that is an important factor for breaking down rocks into soil. And of course, we have climate, weather. So ice, rain, floods, all of these types of climate conditions, the temperature, freezing, thawing cycles, all of these things really are important for forming soil. And then there's some things, and you can kind of maybe lump it with climate, and then in the case of a glacier, but there could be external forces. Something can come through an area and totally change it. It can bring in a bunch of gunk from hundreds and hundreds of miles away. It can bring in new materials, and then the soil can get changed from that. So sometimes you'll hear people say it's parent material, or what was the action that happened to cause your soil to be. And then there's, time. These things take a long time, hundreds and hundreds of years for, soil to or minerals to weather away into something similar to soil. So time is going to be always in the background, and it's also very important for how soil is created. So we'll pick apart here glaciers. So glaciers are incredibly important for the soils that we see here in Minnesota. And it's not just, the till part, which is some people get it turned around, just the glacier moving junk and creating kind of these bases that turn into soil. So that would be till. So the bulldozer. So think of a glacier as a bulldozer. All of the stuff gets shoved and then it stays in place and turns into soil over time. There's something called loess, which is very silty, and we'll talk about what silt is later. But a lot of times after glaciers melt, there are certain situations where lots of winds come up, and if there's a dry area where a glacier was but is no longer, and you have kind of some exposed soil, that material can get picked up by wind and deposited quite a ways away. So even if you don't have an area where you have a glacier that plowed through it, you could still have things like loess, which is blown in from the wind. There's other ones, the lacustrine, the lake bottoms. So, is anybody familiar with the Red River Valley? So, if you look over here, let me get my highlighter here. So, this red section over here is the Red River Valley. Does anyone want to say like what types of soils are up here? Are they really clayey, mucky? What do you think about when you see these soils up here? If anybody has any family, or what's something that they kind of deal with a lot up here too? Feel free to enter in the chat. Nobody has any family up there? Really? Okay. Well, up there in the Red River Valley, their soils, a lot of it was formed by, lakes that eventually, over time, kind of settled out and formed the base of soils. So you'll see a lot of that here in red, and there's some other spots. A lot of times these were ancient glacial lakes, and the material just kind of sat there over time and sorted itself out. But usually they're pretty clayey, these types of areas. They don't drain super well. So if you're ever heard about Red River floods, there's a lot of challenges in those areas. The topography is pretty flat, but the soils are really poorly drained in a lot of places. So you might see that a lot. Outwash is a fancy kind of word, but usually it's think about a stream or a river that's near your home. You know how there's gravel and sand and things that are maybe on the edges. You can kind of think of like that is outwash. So some of those places that have outwash might have really well drained soils, might be a little bit more sandier than normal. I live around here in this area, and St. Peter is right around there or so. And the soils there are pretty porous, so lots of things can go into them from above. So in some cases, they're very concerned about what is going on above because it could affect people's drinking water. So outwash and some of those spots, you can kind of trace it back to all the way when you had little glacial rivers going in. And then there's bedrock. So a lot of times we talk about glaciers, we talk about things that move fast and cause big things. But in some cases, the soil just kind of forms where it starts. So you might see spots in northeast Minnesota where they're still kind of in that bedrock form. And then there's some till there as well. It's a little complicated, and you can see how complicated it is. I'm not going to go through this because I don't want to scare or traumatize anybody, but I simplified glaciers a lot. So Minnesota has glaciers didn't all just come in one giant sheet and they didn't all melt at the same time. Sometimes we've had multiple glaciers go through an area over tens of thousands of years. Some melt away fast while others remain, and these cause even different things with our soils. And this here from you can kind of see a Lake Agassiz, which was an ancient prehistoric lake. And if you look at the previous slide, so this is kind of the Red River Valley area, right? It's a Lake Agassiz. Oh gosh, wow, that matched up pretty dang well. Maybe because it formed from lake bottoms, right? So again, we can kind of look in the deep past to see how our soils and some of the characteristics we see today. So now we're going to get into the real nitty-gritty, right? A lot of people mention the mineral parts of soil. So we'll start off there and we'll kind of branch away a little bit. Let's see if anybody has any questions. Red River Valley, very fertile. Yes, it is. And Cheryl has a great a point. When I say a lot of these things, when there's lots of clay or if there's clay-rich soils, and I'll even go back to my county here too in Blue Earth. Clay soils are very fertile. Clay, and we'll talk a little bit about maybe why that is. But we'll stick here with soil texture and we'll kind of go through here. So you might hear us say things like sand, silt, clay. These are kind of your building blocks, your mineral part of your soil that some people might be familiar with. They might have heard definitely clay. How many times have I gotten a phone call saying clay this, clay that? There's silt and there's sand. So they're all formed from, a smorgasbord of rocks. But as weather and as those soil forming things happen, they break down into small pieces. And we can categorize them by size. So you'll see sand, fine sand, silt, and clay. I don't want you to get hung up on the numbers. The big thing I want to show you is that clay is so tiny compared to sand and even silt. And this will be important when we talk about the differences between these three types of particles. So I like to think about it if I'm in the garden or if I'm in the woods and I'm thinking about planting a tree and I think about sand, silt, clay, my mind goes to almost like rock, paper, scissors, right? So each of these categories of soil minerals have their strengths and have their weaknesses. So we rarely want to have a soil that has all sand or all clay or all silt. So, but they all have little bits of characteristics that can change how we grow plants. So we'll start with the biggest small particle, which is sand. So when we think of sand or sandier soils, we might think of, hey, drains real well, water goes right through. Not always, but a lot of times we might see that where it drains real fast. There's plenty of air pockets in the soil. We'll talk a little bit about why that's important for plants. Some folks will think it's easy to work or easy to shovel it around. Again, there could be other things coming into play that make that not true, but you might hear that a lot when people are dealing with sandier soils. One of the bad things is because it drains so well, it's kind of hard to hold on to water. The types of water that plants need, it's not great at holding that together. It's much better at helping plant roots get enough air to survive, but when it comes to holding on water, they just can't do it. And as far as nutrient holding, so when we talk about these particles, all of these can hold nutrients. You can kind of think of them as bank accounts, right? So sand's bank account is pretty, you can't really deposit a ton of money. You can put money in there, right? Nutrients, but it can only hold so much in the bank vault, right? So sand oftentimes has poor nutrients. But I wanted people to think about, when we talk about sand, I don't want to have it be like a desert or it's ugly or not important at all. So, Anoka Sand Plains has many beautiful spots. I don't want to have, badmouth sand and talk about how bad it is when there are really beautiful areas where plants and trees have all adapted to these types of soils. So just a little bit of stepping back and taking stock. Not everything's so bad. Now we're going to mention up to silt. So silt is really interesting. It's probably the most interesting, in my opinion, of the three. It provides a decent amount of drainage, not as much as sand, but it can drain a little bit. It has some decent, it's almost like the medium of everything. I'd say it's so with drainage. It's so for air pore space. It holds water, but not too tightly. So plants oftentimes are really happy if their roots find a silt that's holding onto some water. The biggest problem with silt is how easily erodible it is, both from water and wind. So when we talked about loess as one of the soil forming parent materials, that was predominantly wind and then also a little bit of water too. But it kind of gets it from both ends. So sand can be blown around by wind. Clay has a very special characteristic that makes it a little harder to erode, and they can all erode. All of these particles can erode, but silt gets the worst of both worlds in terms of what it's susceptible to. It's also not the best in terms of shear strength. So has anybody seen, maybe on a cliffside or a hill where you see some sloughing? A lot of times silt is one of those minerals that seems to be kind of hard, concentrated in some sloughing areas. It is better than sand for nutrients, but it is not the best. And we'll talk about one that is the best coming up here soon. Has anybody been to the Loess Hills in Iowa? You can type in the chat. So just like we dealt with glaciers here in Minnesota, Iowa dealt with a lot of glaciers as well. And again, when you have these big masses of glaciers, you have wind whipping around, you can move some of that silt, right? Because it's easily erodible. So you might see hills or hills that are predominantly made of very silty soils. So the Loess Hills is a really beautiful spot in Iowa where you can kind of see some of this. But you'll notice that there's not a lot of houses that are built right on the top of these hills, right? Because it's not super strong. It can fall and slough off if it's disturbed. So again, we have those spots here in Minnesota as well, but just something I wanted to show you that and it's in other states too. Now we're going to get to the grand champion, clay. Clay is extremely tiny. You even saw that on the screen there. It almost looked like somebody maybe put a little speck of dirt on your screen on your laptop. I'll show you. It's like, look how tiny that is. I bet you can't even see the dot, right? That is how small clay is. But what it makes up for is the surface area. So this is a really tiny particle, and a lot of times, a lot of clay is almost like this platey kind of thing. that has a lot of surface area, right? So it might be tiny, but there's tons of things that can go on here on this surface. And as Cheryl mentioned earlier about the really rich soils up in the Red River Valley, clay is a good reason why it can hold a lot of these nutrients that plants need to grow. It's not so great with drainage. That can be okay in some cases, maybe if you're dealing with a historic drought, right? So there's a few spots here in Mankato where the community garden here, they have a really rough spot with heavy clay. And one of the things that during this historic drought, it was a little better at holding on to some water and it was a little bit more damper than other areas. So they had a really great harvest, even though it was quite a bad drought. So again, I don't want to badmouth clay or sand or any of these other particles. They all have their pros and cons. Because you're dealing with such a small area and that can be compacted pretty easily, we start to worry about are the roots and plants getting enough air? So that is one of the concerns with really clay soils. They can be compacted if you do a few naughty things, and we'll talk about those later. But again, we're going to be worried about the airspace. And then there's certain types of clays that can swell and shrink, and that can cause other issues, especially with certain construction houses and foundations. But again, clay is so unique. I could spend 3 days talking about all the different types of clays, but we are not going to do that today because I don't want to make Emily mad at me, and I don't want you guys to log off too early. So again, I'm from Mankato. I'm going to talk a little bit about our soils here are pretty clayey too. We did have an ancient glacier lake that was around here. We had a lot of this type of clay that gathered over time. So one of the early European explorers in this part of Minnesota was thoroughly convinced that he found a very special type of clay that would make him and all of his French friends rich. And it was a type of blue clay. Of course, the people that have lived here in Minnesota for thousands and thousands of years have already used that for lots of different things. But Mr. LeSueur thought it was copper rich, like he was going to operate a mining place here. And surprise, surprise, that is not true. So sometimes when I think about Blue Earth and where we get our name, this type of clay is kind of comes to mind. So a clay that is lends its name to our county here. So if you're looking at your soil, and you're looking at how the mixtures of clay and silt and sand, how does that all come together? Like, what do you call your soil? Is it a clay? Is it a clay loam, a sandy loam? So we'll use this texture triangle to try to figure things out. So if you get, if you have a 30% of clay, you'll draw a line right there, start at the 30, and draw it across. And then maybe you have, I don't know, uh 45% sand, right? And then we'll cross over here. So we got a point. And then if you wanted to get fancy and make it look really nice, then you can also do it for silt. But Or silt and sand. So when all of those points meet, that'll tell you what type of soil you're dealing with. So this is a question. You don't need to do anything. Just want to hear your predictions. If I had a jar that was 33% clay and 33% sand and 33% silt, would that be a loam? So a lot of times people will say loam is like a good mix of everything. If I had equal amounts of all three or each of them, would that be called a true loam? So we want to, one of these is a little bit more powerful than another. So I hear your predictions. If I had them all equal, would it be a loam or not? Yes, Susan says yes. Other guesses? Clay loam. I think she got it, Melissa. Very good. So clay is pound for pound, I like to think of it, stronger than the other two in terms of what characteristics it gives a soil. So actually, she's right on the money. It is a type of clay loam if it's all equal. So clay is a little bit more powerful than the other two just because of its surface area. So when you look at things that are true loams, they'll have a little less than 33% clay. There are a couple things that you can do at home to kind of get an idea, and there's a lot of great resources online to tell you exactly what type of soil you might be dealing with. One way I like to do is called a ribbon test, where you wet a clod of soil and move it between your fingers. And depending on how long the ribbon you make is, that tells you a little bit of how much clay, gives you a rough idea of how much clay is in there. You can also do other things where the feeling is also important. So if it feels slick or flowery, might be more of a silt. Sticky would be kind of your clay, and gritty might be your sand. So there's a couple different ways you can figure it out by just feeling. There's also another kind of fun way to do it at home is finding some soil in your yard, putting it in a jar and making sure it's really broken up well. Otherwise, it doesn't work that well. Again, this is something fun to do. This is not a scientific, very exact science here, but you can shake the jar with your soil, and then over time, certain parts will settle out. So the bigger parts, like your sand, will settle out kind of first, then your silt, and then your clay will probably be suspended in the water for a really long time. So based on how long time has passed, you can kind of that's another way to have a fun estimate of your clay in your silt in your sand. I get this question. I think how many times have you gotten this, Emily? You want to
Good amount
give
of times.
a good amount of times, right? I have a sandy soil and I want to make it clayey. I have a clayey soil and I want to make it sandy. Um, Again, in the vast majority of cases, it's not going to work. Um, you're skipping a lot of those soil formation factors, right? So a lot of those soils have had thousands and thousands of years to kind of develop, and just throwing a bunch of sand and hoping things work out. More likely than not, you're going to get into an issue. And then if you take a rough estimate of how much of the soil and weight, so if you would take a 6 inches or so, stick a shovel in there, and I took a 6 inch slice across a whole acre, a really rough estimate is it's about 2 million pounds heavy. So that's just the top 6 inches across an acre. Uh, how much money does 1 million pounds of sand cost, or 1 million pounds of clay or silt, if you wanted to change an acre, just an acre? So again, think about that. It's really hard to artificially change the characteristics of our soil by adding kind of a little bit of sand to a clay soil and vice versa. Also, kind of one of the things that you run the risk of, and it doesn't happen all of the time, but it does happen quite a bit. If you add sand and clay and certain mixtures and you mix it up, it can become even more dense than it was before. I had a homeowner that I worked with, unfortunately, in Blue Earth County. She got a not quite this dump truck full of sand, but she did get a lot of sand and mixed it with her very heavy clay soil. Remember, this is Blue Earth County. Nothing grew there. She may have permanently damaged that part of the yard. It's going to be very expensive to kind of take all of that out and refill it. And even then, you might have issues. So please don't do that. This is something fun I found online. So this guy has a blog where he talks about how to make clay ovens, right? And to, cook pizzas or whatever have you. You know how he built it? He took clay and he mixed it with sand to make kind of a plaster. Okay. And then he cooked into it and kind of crisp it up and he was able to use it. So sand and clay. Okay, be careful when you're doing little experiments in your yard. You don't want to end up making a concrete-like mixture. Looking at the soil, kind of stepping back here, we're not just talking about those sand, silt, clay. A lot of times they organize themselves into layers, right? And these layers all also have different characteristics. So we call them horizons. Soil scientists will call them horizons. So if you took a big slice out of a side of a hill or something, you'll see kind of little layers, right? Little layer cake of different characteristics of soil, different minerals. So a lot of times you might hear farmers and other people talking about their A horizon or topsoil. That's kind of what we're hoping for when we're growing vegetables and where a lot of our tree roots are at in this topsoil area. It tends to have a darker color because there's organic matter in there, and some types of clays can cause darker colors. But the structure might be kind of what we think of when we think of soil. As we go deeper in the ground, we run into other things that are different. There's less organic matter in the deeper layers of the soil. They may not drain as well. They may have really high pH, which we'll talk about later. And other things will be different. So, again, after thousands and thousands of years, you're going to see soils kind of get separated out into these layers because we're dealing with plants, we're dealing with weathering, we're dealing with things coming in, things being eroded. And over time, that makes these layers form. Christina has a question about taking a soil sample for testing for my veggie garden. How deep should I dig? That's a great question. Typically, Emily, correct me if I'm wrong, we want to go kind of 6 to 8 inches, but our soil test will tell you from the University of Minnesota will tell you how deep, depending on if you're dealing with a lawn, a pasture, a garden. What do you think, Emily?
Yeah, it's usually 6 to 8 is what I usually tell people.
Yep. And then you're right into this area. So hopefully your soil at least has 6 to 8 inches of this A horizon, this really nice material for roots and plants. That's what we want to sample because that's where the majority of the roots are for a lot of different species. You might have roots that kind of go down to the B horizon, but there are really not very many. You might have roots go even deeper. Those roots are, if you do have like prairie plants that go very, very deep, a lot of times they're just trying to get water. But the majority of the roots are going to be kind of in this A horizon because that's where all the minerals are. That's where all the nutrition is. Your topsoil is precious, right? This A horizon, it does not form easily. Does anyone take a look outside yesterday when we had the 50-mile-an-hour winds? I'll tell you what I saw. I was driving up through the Becker area, and I wasn't in the snow squall, but there was quite a bit heavy winds. There was a little bit of snow, but I'll tell you, snow doesn't look brown. So there were a couple fields there that were open. So there was quite a lot of soil moving yesterday. Places that had trees that were blocking it as windbreaks was better. Uh, Places that had lots of residue were better, but places that had nothing on the soil and we were exposed to 50-mile-an-hour winds, even though it's wintertime, you can lose a lot of soil. So we think of the Dust Bowl, we think of things that happen in the summer, but I'll tell you, in wintertime, we can lose a lot of soil too. I hinted at this earlier, but we talked about layers of soil and what can happen if things get mixed up or changed. How often go ahead and put in the comments, have you guys ever seen silver maples or pin oaks or other types of trees kind of look like this, really yellow or looks like they have green veins and yellow leaves? Go ahead and type in the chat if you've seen that. A lot of times I find this in when I was in extension, I was going to a lot of old parts of town here in Mankato, places where there was really heavy development. Yes, lots of people have seen it. So, not always, but one of the causes, and we always want to look at planting the right tree in the right spot, right? But when you mix up, let me get this here. When you mix up a lot of these horizons, sometimes in my part of Minnesota, this horizon here that we call the subsoil, that tends to have a very high pH. Another word for high pH is alkaline, right? So, in a normal situation, normal with quotes, you might have kind of a close to neutral or maybe a slightly acidic topsoil or a horizon. But once you get into construction, a lot of times your horizons are all mushed and mixed together. So a lot of the characteristics that we would normally expect could get really changed. So in a lot of those cases that I dealt with where you had what we call chlorotic trees, where they have this issue here, the plant is having a hard time uptaking certain types of metals, iron, manganese, there's a few others. But a large part of that reason is that the pH is too high. And why is the pH too high? Because the soil got mixed up like this. And when we think of tree roots don't go very deep either. And I'll show you a photo here later, but and they don't go as deep as you think. So a lot of times trees can be affected just like a vegetable could. So we'll here going to texture. So this is something that we as humans have a little bit of power over. So we talked about soil and how air and water are all important to keep our plants healthy. So when we talk about pores in the soil, you'll see little parts of minerals. These could be silt, sand, clay. You could have silt with clay attached to it, but they can sometimes form these little clods or little crumbs. And how these crumbs interact with one another can really help us figure out if we're dealing with a water drainage issue or we're dealing with compaction or there's not enough air for our roots. Remember, roots need a little bit of air, not a whole ton, but depending on the species of tree or plant, they do need a little bit of air in the ground because roots are burning sugar. So if you were to look at something, quote unquote, an ideal soil, you are looking at how much of it is actual physical minerals, how much of it is water, how much of it's air, and then we also have organic matter, which we'll touch on later. But having these in balance for the plants and species that you have on your land is very important. So, soil structure is something like we humans have control over, as I mentioned. So, a lot of times, what we do in our yard or what we do in our woods has a really big impact about structure. We can have it really nice. And a lot of times, what we're looking for, particularly if we're planting vegetables or annual crops, or a lot of herbaceous plants anyway, is we want to kind of look at this crumb kind of structure. This is a photo from Iowa State where they looked at two different fields that were under really different management. So this one on the left here was under pasture for a long time, no, was never tilled. The one on the right was very intensively tilled. So you can see how crummy, so to speak, it is over here, this healthy soil, compared to very cloddy, and sometimes you can have big masses of stuff. When they're all massive like that, we don't have a lot of pore space. So that can cause issues for us. So earthworms, they're very important for structure in some soils. A lot of times we think earthworms are good, and a decent amount are, if they're in our garden. And if you were to ask some of my forestry, natural resource people, they would be very against even the earthworms that we see. But jumping worms, has anybody heard of jumping worms? I'm sure you probably heard something, but if you haven't, these are invasive worms that are brought over. And one of the things that they do is they create their casings, or they eat a lot of stuff on the surface. They don't really go deep in the soil that much. They create a type of structure, or soil structure that looks a little bit more like coffee grounds than it is like a crumb, cookie crumbs. And that makes it really easy to erode away. And if you see this on a slope or something along those lines, you can see um, water and wind can take away that layer of soil and expose roots that are not used to this much air, and that can cause issues. So when we talk about trees specifically, I hinted at this earlier, your roots are only, most of tree roots are 2 feet deep, if that. Vast majority are shallower. So when we think about roots being exposed, and if you're in a jumping worm situation, if you're on a slope particularly, that could be really damaging for trees and plants. So when we think about trees, don't think of it as a huge anchor, upside down kind of tree thing. It's more shallower than you think, especially when you see storms and you might see trees get uprooted. You'll definitely kind of see how shallow some of these trees are. So compaction, when we go out there and stomp around with our feet, we can close those air spaces. That causes issues for our roots. It might, when it gets harder to drain the soil, as these things get kind of compressed, and the structure is gone. So we don't have nice little spots here where water can filter down. It gets kind of stuck. And depending on your texture, it might be held really tightly. So clay can hold on to water pretty tight, and that can cause issues too. So clay soils can make it worse. When we have really bad soil structure and we have really intensive rainfall, we can have something called crust, a soil crust that can form on the top of our garden, and that can cause issues for our seedlings. So if we're dealing with really bad soil structure, sometimes certain plants, particularly things like peas, things like corn are a little bit better at the poking through crusts than something like a pea or soybean. When they get up like this is very sensitive. And if the crust is really hard enough, that can snap off and possibly kill your seedling. So we're dealing with impacts here in real life when we talk about soil health. So tillage can do a couple different things. We talked about compaction. Maybe you have a big, heavy piece of equipment that goes across here, squishes the soil a bit, especially when it's wet. That's kind of what we see here. We can have some issues there. But also, if you're in your garden and you have a rototiller, hey, I've been guilty of this. I've used rototillers before. They can be very useful. But when you use rototillers, you're breaking up that structure into fine pieces, and those fine pieces can be lost. So there are certain points where you're doing way too much tillage, you can be damaging your structure. And then this is an example of a plow layer. You might hear farmers talk about a plow layer. A lot of times when we talk about that 6 to 8 inches, that's where a lot of the roots are. That's also where your tillage implements tend to be, your plows and such. So over time, they'll hit the ground and they'll kind of almost smear it over time, and you'll get a really hard pan here, and that can cause issues with your structure and drainage. So when we look at bad drainage, it could be from, you might have just a really tough clay soil, but it also could be from what you do as a gardener. There's a lot of great ways to test your drainage. And one of the ways is to simply dig a hole, fill it with water, and see how long it drains. So urban forestry, Gary Johnson, our emeritus professor, has a really great video about how you can do these tests at home. But water really doesn't like big texture changes. This kind of goes to where if you put a big layer of sand, a uniform layer of sand, and then maybe you have silt right above it, just how water physics works. A lot of times, what will happen is the water will come and will saturate this area, this layer of silt first, then it will go down to the next layer. Even though it's sand, right? We talk about sand having really great drainage, just how capillary action works and how water works, it takes a while for that to happen. So sometimes you can get it's hard to see on this old picture, 1959 is when this was done, and it's still very useful today. Sometimes you'll get ponding of water on the boundary here. Some people might call it a perched water table, but when that happens, it can be really bad for roots. So sometimes where I see people making mistakes is they'll bring in really, really clayey topsoil. They'll put it on top of an existing texture, right? So you might have a sandy soil and you'll put a big load of really clayey topsoil on top. You can have this situation. So when water encounters a big texture difference that's uniform, you can have these bad things happen. This kind of goes into the old saw where people put gravel in their plant containers. Don't do that. It doesn't make it drain better. A lot of times what you're doing is you're pushing that water. You're reducing the amount of soil your roots have to explore because it's hitting that big texture difference, right? Even though we're dealing with gravel or sand or something, we're again hitting that crazy texture difference. So we talked about how important soils are to hold nutrients. This is very complicated. You don't need to remember this, but just know that clay has very interesting negative charges. There's organic matter also that kind of hangs out here that has positive and negative charges. And all of the plant nutrients are going to be attached or be attracted to those areas. And our plant roots come in and can take a little bit of those. So again, our soil is really important to hold nutrients. We don't have enough time today. I'm trying to get through here so we have some time to questions. But organic matter is really important because organic matter is it's not sand, silt, or clay, but it has really powerful characteristics. One of the things it does very well is it helps with structure. And it can do this by kind of globbing up our soil to make sure that we have water infiltrate. It can reduce compaction to some extent, and it can also be a good reservoir of nutrients. But here's the issue. We have situations where people are adding a lot of compost, a lot of organic matter, lots and lots and lots. Because a lot of the things we hear about organic matter is really great. It can fix a lot of things and it does help. But there's certainly a point where if you're adding way too much organic matter in the form of compost or manure, these have important consequences for our area. Certain types of nutrients, particularly phosphorus, which can be a water pollutant, can build up in the soil over time. And then if that soil leaves your land, it can cause issues downstream. Organic matter can also break down and decompose. So a lot of times it turns into CO2 or kind of almost disappears. And you'll see kind of a situation here where a person planted a tree and filled the hole not with the backfilled soil, but with nothing but compost. And then maybe a year or two later, they come out and they see that it's sunken down. There's a very complicated word for this. It's called subsidence. But just be aware that or compost, we want to make sure that when we add compost and manure, we add it according to the plant needs and not extra. So again, it's one of those things where we think compost, there's no bad things that can happen. Definitely bad things that can happen. This is a great example where we looked at phosphorus buildup in soil tests that the university analyzed. And this is how we measure phosphorus concentrations in your soil. So usually 40 is really high even for vegetables. So when we look at all of the samples that were sent in compared to farm and field, uh, people are putting a lot of compost in their lawns, their gardens, and they have really, 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 really enriched soils with phosphorus. And again, if it leaves your garden or leaves your farm, that definitely can cause issues. So just be aware of that. So just the last few slides here before I stop to take questions. What can we do to have a healthy soil? The one thing I tell people is that there's no shortcuts. You can add a bunch of compost, you can get great harvests, but again, we run into those issues of perhaps water quality or other issues like subsidence, where it kind of disappears over time, decomposes. So there's some things that we can do. I don't think everybody can do no-till vegetable gardening. It's very difficult, but there are farmers that do it and do it well. So if you have a vegetable garden, a lot of times people that use less tillage, even that would be a big win. If you can just reduce maybe one or two tillage passes, or maybe not go so crazy with the rototiller, that might make a good difference with our soil structure. So this is a broad fork, and that is another way that you can kind of do a little bit of semi-tillage, right? But still not be super disturbing to your topsoil. There are other things that you can do incorporating cover crops in your garden that can add organic matter kind of sustainably, and also have other benefits like maybe pollinator habitat or protecting the soil from 50-mile-an-hour winds that we just had yesterday, right? So even when they're dead, their residue can provide some protection and catch snow even. So again, there's things that we can do. There are no potions, juices, teas that can make your soil all of a sudden healthy. There's no easy way out of this, folks. You got to kind of take years and years to kind of get your soil healthy. It's not easy. If it was easy, everybody would be doing it, and it's not. But the rewards are you can keep a resilient garden that can stand up to some of the things Mother Nature can throw at it, right? Some people want to, can you pay for soil health tests? I'm not against that at all. A lot of times I caution people to say that a lot of times when you send something in for a soil health test, not a soil nutrient test, right? Soil health test, um, you're taking a snapshot in time, and you really should be comparing it to another spot, maybe a place that never had a garden, or other types of never been farmed, or maybe a fence row. Comparing it in a close area because you're just taking a snapshot in time, and a lot of soil health tests are relative. And again, that's another hour discussion, which we do not have time for. I'm going to send people to do soil tests. This will help prevent us from adding way too much manure or compost or potash or whatever nutrient you're putting in. Know what your plants need. Okay. So the University of Minnesota Extension has great resources for you. Emily can be very helpful. If you're dealing with compaction with trees, sometimes mulch can be great. Mulch can break down over time and turn into organic matter, which can help our soil. Okay. So a lot of times people spend lots of money doing something called vertical, oh gosh, I don't even remember what it was called, but vertical tillage on your trees. There are ways that professional arborists can do it that is also very effective called air spading, where the roots are not harmed if you do have a really compacted area, maybe from foot traffic. But again, we want you to work with your land instead of against it. Look at your soils, pick your trees, pick your plants to adapt to that spot. We have plenty of resources on the University of Minnesota Extension webpage about picking the right plant for the right spot. Just a few examples here. Rain gardens can be very useful in certain situations where it's a little bit wetter than we'd like. If you have really, really tough soils and you don't want to spend the time to do the long way, looking at raised beds or containers, going to a community garden, working with neighbors. Maybe they have a plot of land and you guys can take turns or grow each other different vegetables that maybe work better in one area versus another. So there's lots of different things we can do. We had a lot of things to discuss, and I think I have just a few minutes for questions, but it's a lot to send at you. Yeah, I'd be happy to answer any questions while we have some time here.
Thanks, Shane. First question. My garden soil is really compacted, probably from tilling. Without tilling it, it would be so compacted. How do I
Mhm.
make the soil plantable without using the tiller? I know you kind of
Right.
touched on that a little bit, but
Yep.
maybe
So
what are
in that
some
situation,
cover crops that could make it less compacted, maybe?
right. So we can do this a couple different ways. Container gardening might be applicable to your situation. Again, there are containers as well, so you don't necessarily have to have a giant raised bed. A lot of times, if you are a tomato fiend like me, just having a couple containers, maybe 10-gallon or 5-gallon, containers of tomatoes, right? If you really need your fix. There are some varieties of vegetables and trees and other things that might be a little bit better for clayey soils, but I hear you. This stuff is not easy. We can't, it takes years and years to try to sustainably get some of these soils to a workable condition. And if you don't have that time, that's fine. But we can look at some of these other things. I think there's more community gardens out there, um, more and more. So a lot of times, if you live in an apartment or if you have a really difficult site, maybe that there's lead contamination. That's another issue with depending on where you live. So some of those might be your best bet, but I agree it's difficult. And again, very heavy clay soils are difficult, but not impossible. There are people that do no-till and do other types of sustainable organic amendments to their soil. Um, but it takes a lot of time. It's not easy.
Next one, what should I expect to be the soil mix used to create a raised bed garden?
That's a great question. I think when I was in extension and I did a little talk about this, and there's each extension service you go to will give you a different formula for a raised bed fill, like what is the best. The one thing I will caution people is going super heavy on topsoil. Topsoil can be a part of a lot of those mixes, but depending on what type of texture we're dealing with, the thing you don't want to have is getting in your situation where you have a lot of clay topsoil you put in a raised bed, and you're not using some of the other composts or vermiculite or other things that not sand, not sand, but other things that can help. That's kind of the one thing I caution people. There's a lot of extension services with, and maybe Emily can share some, but the that have different recipes. Typically, there's an organic component. There might be a little bit of topsoil. There might be other things, but again, adding sand and clay, please don't.
Next one, how much mushroom compost could I add to my raised garden bed?
Yeah, that's a great question. So one of the things that when I talked about phosphorus, um, if you're worried about having too much phosphorus, using things that come from plants or fungi might be less enriched in phosphorus than maybe an animal manure. But it's very difficult to accurately put the compost. Like, let's say you're using mushroom compost to satisfy a nitrogen requirement on your plants or other things. If they don't give you a good estimate on the bag, like, when we talk about like a 10-10-10, right? The percentage of nutrients, right? If it doesn't have it on there, that can be very challenging. And a lot of times composts can be analyzed for nutrients so that you can apply the right amount, but they can change. Like, if you get your mushroom compost and it's from one farm and then you go get it from another, they can have very, very different nutrient contents. And the rub is those tests are not cheap. Um, a lot of times you might have to go to other certified labs. I think maybe the cheapest one I've seen is $60 or so. But they can get kind of pricey. They can get much pricier than that.
Mhm. No other questions right now. So if you have a question, please put it in the chat or the Q&A. And we'll give people a few more minutes. But just a
Yeah.
reminder that these webinars are recorded, and I'll send out the recording to everyone that registered. And then these will also be posted to YouTube as well. So if you want to find it on YouTube, you can go to Meeker County Extension, search that in your YouTube search bar. And then it should pop up right away. Just click on that and then go to videos, and they should all be there for you guys to rewatch.
Mhm.
So, seeing that we're not having any other questions in the chat, thank you, Shane, for being
Thanks,
here. Really
Emily.
appreciate it.
Yeah.
And once everyone leaves, make sure that you complete the survey that will pop up on your screen. Okay, it looks like we have one more question.
Oh, I see. Great. A pH question. That's great. I love it.
How to
Um,
regulate pH balance in the soil.
right. So, hey, the soil test that you can get from the university does give you a pH reading. I will say that it is easier to make a soil that might be a little too acidic into a neutral soil than it is to acidify a soil. So making a basic or alkaline soil into neutral. Um, we do have some resources on our website for acidifying. There's a lot of guesswork. If your soil is very high pH, it may not be practical to lower it down to maybe a 6.5 or 7 that most vegetables and lots of trees might like. If you find yourself in a situation where you have a very high pH, that's where we want to shift to the right plant, right place. Hate doing this, but I ruin people's dreams when they say I want to grow blueberries and they show me a pH test that says 8.0. Um, that can be very challenging, and we don't have a lot of great success stories about really lowering it from a really high pH to a neutral to low. Um, if you find yourself in a situation where maybe you're a little acidic and you're going to go up to neutral, lime often, farmers do that a lot around me. Um, Over time, sometimes based on the products they use to grow their crops, sometimes they'll need to periodically add lime to raise the pH. That seems to work better than it is to acidify it. It's just how it is. I wish it was easier, but it's not. Some people use sulfur, elemental sulfur, that can take many years to acidify your soil. Some people, particularly what I recommended is if you're just kind of a little bit high, maybe you're 7.6, 7.7, something around there, under 8, but you're still high. Changing your nitrogen fertilizer to a more acidic form can help a little. It's not going to crash it or do anything crazy, but that way you're getting your nitrogen requirement and you're also kind of making a dent in your alkaline soil. So,
Awesome. Well, thank you, Shane. Thank you, everyone, for joining us tonight. And we will see you next Thursday for our last session on maple syrup.